This right here is an H bridge or an H bridge, depending on how you pronounce it. And basically, it's a pretty cool circuit that allows you to control the direction and how a DC motor spins. So welcome back to Knowledge on Ears, and let's get straight into it. So we already know that a DC motor spins continuously. When you connect it to power, it just keeps on spinning. But with an H bridge, you can actually control the direction of the motor, and you can also make it stop immediately. So let's check it out with this H bridge that I just made. Obviously, most H bridges are not this big. They're very small, they're very compact and integrated into some type of motor controller or driver. But this is just one I made. So we have it connected to a 9-volt power supply, a 9-volt adapter, and this is our power supply, where we are providing 5 volts. So there's 4 switches. If I press both of these switches, it will move in one direction. Let me press them. So it's moving that way. If I press the other two, it moves the other way. So it started moving the other way. That's how it works. It helps you change the direction. However, if I press one of these 2 switches right here and I have it move, if I suddenly press this switch, I can instantly stop it. If I press these 2 switches or these 2 switches right here, I can instantly stop it. So let's see it again. Without pressing that second switch, it keeps on coasting. But if I press the second switch, it instantly stops. So now let's get into exactly how the H bridges work. So right here we have a very basic circuit diagram of how the H bridge works. So it looks like this, and it's a pretty simple diagram. It's just a parallel circuit. We have 4 switches and we have the motor in the center. And we also have VCC, the 5 volts, and ground. So basically, H bridges, you don't always necessarily have to work with an H bridge when you're working with DC motors. Obviously, if you want the DC motor to just keep going forever and ever in one direction, you don't need an H bridge. But often when you're working with DC motors or any type of motor in general, you have some type of motor driver or motor controller. And in those motor controllers, there are small integrated circuits that are similar to the H bridge. For DC motors specifically, you'll typically find a H bridge inside one of those DC motor drivers. So yeah, you typically don't have to straight up work with them, but you normally do work with them when you use motor drivers. So back to the circuit. Right here we have 4 switches and our motor. And how it works is that in the example, if you remember, we clicked 2 switches at once to help it move and change direction. Those switches are corresponding to these 2 switches and these 2 switches. So if I click both of these switches, what is happening? So we have the current flowing from here down here, and since this path is still open and I'm not clicking the switch to make it closed, it passes through here, through the motor, which is, I forgot to add something. We have a positive and negative side to the motor, obviously. So it passes through the motor, through the positive side to the negative side, and it passes through this closed switch because we're pressing the switch into ground. So that's creating a complete circuit, and it's making the motor turn in a certain direction. So that helps it to turn in one direction. What about the other way? Well, if we leave both of these open and we close both of these and we press both of these switches, we have it go in the other direction. So now it's going from the negative side to the positive side. But obviously, remember, for a DC motor, it doesn't matter which side the current flows through. What happens instead is that when you switch the polarity of where the current is flowing, the motor starts changing the direction it's spinning in. So in this case, the direction is spinning in the other way. Then it's going to ground. So that's how that works. That's the basic. It's very simple. It is a parallel circuit in theory, but the current is flowing in a series kind of pathway. So yeah, now, if you press, what do you think will happen if we press only both of these? It's gonna short circuit, obviously, because the current is not flowing through the motor at all. It's just literally flowing through this path of least resistance. So that's gonna happen. So now I showed you how I can make the motor coast and keep moving, or I can make it stop. How that happened is that when you make it coast, you click two buttons, one of these two, and you just let go. And you keep all of them open, and the motor, because of friction in our world, the motor slowly slows down after it is moving. But if you want the motor to brake and you want it to stop instantly, you have to short circuit the motor. And you can do that using both of these switches, or you can also do it using clicking both of these or both of these. Why? So we already explored this pathway, but if I close both of these switches, what will happen? Well, current will start flowing in both ways, and now it's like there's two current pathways and it's gonna short circuit. So that's something that will stop, it'll stop the motor instantly. Same with the other side. So yeah, that's basically how this entire thing works. You can short circuit it to brake using these two or these two, and you can also make it change directions by flipping the polarity. So yeah, I hope you enjoyed the video. Thank you so much for listening. Bye!